This is about Zebra 8, the newest version from our color server Zebra. And I would like to give you an overview of what we have new in that version. And especially we'll talk about proofing. You might ask, why is proofing a necessary feature for a color server, as there are so many proofing rips out there? And indeed, that was our first reaction when our customers asked us. But mostly after they explained the reasoning why they asked us, they said basically, now that more and more people are using ECG, extended color gamut, multicolor printing with not even CMYK colors, so all kind of other colors, like for example in ceramic printing, where CMYK is rather the exception than the norm. There is always the need to work with multicolor profiles, be it a 7-color profile, 8-color, or 6, 5, whatever you want and need. And mostly, if it comes about spot colors, there is as well the need to work with CXF data and spot color data with spectral data. And there are some overprinting of spot colors with process colors or with other spot colors. There you need to have a good spectral color prediction model. And that's all that we have in Zebra already for production printing normally. And those clients told us, okay, we have those proofing grips, but either we have to buy a very expensive additional module to be able to process spot colors and multicolor correctly, or we are a little bit limited in what those proofing grips provide us in terms of support of CXF data and multicolor. We thought, okay, what can we do to help those people that they get good proofs for multicolor? And obviously, what we can't do in the color server is drive the printers directly. But what we can do is provide them with an already color converted, optimized PDF document converted to the proofing's output condition, to the proofer's color space. And then they can simply print that either on their proofing grip with disabled color management, or even with an RGB driver, if you think on those Epsons, Canons, HP printers that you can print with RGB. And mostly that works very well. And that it works very well, we have seen already in the Fogra Multicolor Forum, which was presented at the beginning of this year and was conducted last year, where we used the RGB driver for an Epson P5000 with the CMYK, orange, green, violet, that we simply drove as an RGB printer, profiled it as RGB, and used it to process our 7-color ECG print, iterated that, and got very close delta E's and probably one of the best results here for proofing with an RGB driver. So not necessarily very expensive rip needs to be done. So what I would like to show you a little bit how this has been done. We are looking at such a nice guy here, just a CMYK guy. We have another one here. So that has an output intent from ISO-coated. We have another one here that probably have seen if you've seen my other presentation, where we used the same image here for production printing to convert it to a 7-color indigo. Here I'm using it as it is currently. It is an output intent ISO-coated. It has 3 spot colors included. There's one special spot color, which is not really important for the color rendering, but rather for the production upstream, for cutting and so on. So there's a die cut line, but basically it's a 6-color process, so to speak, because we have CMYK and we have additional spot colors that are overprinting the CMYK parts. So when we predict how that looks like, in reality, we need to predict it in combination with the CMYK under those spot colors. So we'll have that here. And in addition, I will use as well a 7-color image that I have prepared already, converted already to 7 colors, as you can see here in the layers. It uses the additional orange, green, and violet to extend on the gamut to make it more vibrant and looking very powerful in colors. Obviously, I'm using Photoshop here, which doesn't show us the colors in true reality, so it's oversaturated and so on. But that's just Photoshop. It's because it doesn't show us the colors for 7 colors here correctly. But this one I will as well use for proofing for our Epson P5000 in my example here. So let's set up a workflow for this. And as always with our color server, we have the home button here. And with the home button, we can start with the auto setup. And inside the auto setup, we have different setup modes. And one of the new mode here we are looking to is the proofing mode. And we are continuing and can either use an existing device link profile. This is interesting for guys that have created the device link up front. For example, that iterated a proofer to the closest delta E, which can be done, by the way, with Copra. In Copra, we have the iterate module here. So you could create a device link and iterate it until you have the closest delta E. And that device link can then be used inside Zebra, sorry, for the conversion. So let's move that back. Here I want to start from scratch, and I use SmartLink here to build the device link on the fly. I want to use as a simulation color space a 7-color indigo. Here as a sample, I'm setting up the prefer output intent here as well for my other files that I had here, which have used ISO-coded. And my target color space is a proofer here, Epson P5000, that I've profiled. And that would be my basic setup. Typically, you would have to select a SmartLink method, so the method how the device link would be calculated in the background and the rendering intent. But for proofing, well, the rendering intent is absolute colorimetric, so no need to select that rendering intent here. And basically, you don't want to have all those fancy things like exceptions and preserving separations. So all those additional things that you can do in a device link are of no importance either. Therefore, no other option here to choose. So it's quite easy, basically, just source color space and target color space. And one thing you would need for a proof would be a media wedge. And here we have 2 options. We can select an external media wedge, which could be the foreground media wedge, could be a TIFF file, a PDF file. We deliver as well the Ideal Lines CMYK strip, which comes for free, and that is as well integrated in the installer of Zebra. And the other one, which is even more interesting, would be the dynamic media wedge, which would, depending on the output intent and the spot colors in the document, create a media wedge that consists of the color space of the document color space, the simulation color space, plus the spot colors. So that would be a dynamic media wedge, which is what we would want to use here. So that's nearly done now. So we just need to give it a name, 7-color indigo, and it should go to the Epson. To Epson P5000. So that would be our setting here. Another thing I can do with that auto setup wizard would be a soft proofing workflow, and we will do that as well, depending on how timing will be. So let's do this first. Now, if we remember, there have been some spot colors. So before we can actually proof those files that we had here, I need to go into my spot color library and define the library that I want to use. So typically, if you're new to Zebra, the spot color libraries, that's something that you have to fill in. So as a start with Zebra, there is no library in here. So, but you can fill it with all kind of data that you have, 6 FX4 data, for example. You can load Pantone libraries. If you have a Pantone Live access, then we have access to that as well and can load a Pantone Live library like this one, which have always this little icon here that indicate that it's a Pantone Live icon library, and we would load that. And obviously you can load Pantone libraries from other sources that you could have with your instrument, and you can load them. Even ACO files from Photoshop can be loaded. We prefer, obviously, spectral data because that's the best quality conversion you can do with. And what I want to use is this spot color gradients XF that I have incorporated already, which has my two spot colors I'm looking for. First of all, here, the Pantone red, which is only a solid color. If I look into here, I see it has only a full tone here. So I don't have information about gradients here. That's the least information I should provide to the color server so that he knows how that spot color can be or should be converted. So that would be my target LIB values. And for the Pantone Reflex Blue, I have some more information, like the full gradient information. So if I have that information, that's even better, because then I can as well have target values, for example, for the 50% value, which gives us this LIB values. And I want to target that value, and the color server would use that information. And even better, if I would have even some information like printed on black, which is then a full CXF X4 data. If we have all this information, we can as well calculate the opacity from that information. And Zebra would then know, okay, that color is has a certain opacity. So if it interacts with a different color, the other color will either shine through or will be blocked, depending on how opaque that color is. So this information can be available with the information on black. We can override this. So if you are overwriting this and saying, okay, I have a different opacity because I have that information, or I want to try a different opacity level, you can override that. And then it will be shown here, and that's as well a new feature that we have included in Zebra, that either it is a calculated, automatically calculated value, or a custom value if you override or define your own opacities that you want to use. So we need that spot color library here, and we need another library here, which I called non-printing colors. And this one includes my die cut, because my die cut, well, that's not a color I really need for conversion. And here I can simply define this is a non-printing color. So we shouldn't convert it, and we don't want to use that as well in my media wedge. I don't want to have a die cut in my media wedge as a spot color. Therefore, I can exclude it with that little option here, and I need a spot color library for that. So I need two spot color libraries in my configuration. And how to set this up. By the way, there's a new feature as well. This little browser icons here. With that, you can navigate like within the browser from each window to the next you have been in. So that's easier and faster than going to the home button and to the overview button, and then you're here again. So you can do this way as well. So another thing, how to navigate with Zebra is, if you want to go to the configuration itself, you simply select that configuration, double click, and then you're in that configuration. And then there are a few tabs to look into. I don't want to go through each of them. The most important one we are attacking here, first of all, would be the spot colors and the proofing tab. But I want to start here. So that little checkbox here is quite important for our use case, because we want to use one proofing queue and want to throw in 3 different files with different sources, like ISO-coated with spot colors and 7 color in one queue. And this can be done here with that little checkbox and with the default 7 color space if there is no output intent, like in our TIFF file. There won't be one, and therefore it will use that color space as the source for the conversion. So that's how this is set up. We are using absolute colorimetric for proofing. We have a SmartLink method called proofing for this, and that's good to go. Under spot colors, this is where we are now, where we need to select our spot color library. By default, we are using already, if available in a PDFX document, CXF data. If that's available in that file, we would use that information. That's the best information you could get. Therefore, it is used as the first step here. We don't want to use the lab values here, which is a default setting here. We can disable that. And as we want to use our spot color library, I'm looking through my long list of libraries. That's the one I want to use. And I want to use that on top. So that's the first library I want to look into. So the logic here is Zebra would first look into that library. If it finds the spot colors in there, it will take it. If it doesn't find it, it will look into the next selection here, which would be that. Then you could select another and another and another library, and all those Zebra would look through until he finds all his spot colors. And if there are still some spot colors which are undefined, then you would go to that section, undefined spot colors, and here you can say what you want to do with that spot color. For example, in our case, where we have this die cut line, we don't care about the color accuracy. We just want to see it in the proof. Therefore, we could as well use that method here to convert it to with the alternate color space, and we don't care about the color. It should just be there, so we use that. As a calculation method, we are using the precise match option here for proofing, so that's all fine. There's nothing to select here differently. For production printing, that's obviously not the right option here. If we are in production printing, we would use either this option here, use maximum of 3 channels, use this option, or use that, depending on our output condition. But for proofing, we want the best quality. Therefore, we are using that. For the gamut warning, this is typically enabled. And for production printing, for example, we are using a delta E limit of 2.5. For proofing, we want to have a narrower limit. You can set this even higher or lower if you want. So it's depending on our proofer here. So that's all fine. Special options, perhaps the auto setup will set this up for you already. Here you don't have to care about that, but there's at least one thing you should understand, and that's the reason I'm going in here. The merging color space. And this is the color space, for example, if I'm going back here to my CAD image here, this has an output intent ISO coded and has those 2 spot colors here. And those spot colors, if I would print it on my offset print with ISO coded with those 2 spot colors, the merging, the combination of those Pantone colors here with the CMYK would be done in that ISO coded. So it would be in my simulation color space. So in my printing color space, basically. And therefore, we have the possibility here to say, okay, where should that merging appear? Should it be done in the document color space? In our case, for proofing, it would be our document color space, or I could do it as well in the target color space, my proofer color space. And obviously, for proofing, that's not the right choice. We want to simulate how the print would look like and not how the proofer would merge the spot colors. Therefore, the auto setup would select that option automatically for you, so that you don't have to care about that. For normal printing processes, that would be the default, or automatic, basically. But we would use it then for the target color space. For the linearity, we have as well options here to define how the linearity should look like, especially for this one spot color that I had here, which hadn't any tint values. And for non-tint values, the ISO 2654 is a good method to use. And I'm going to use that here now too. The other ones are of no big importance here, but those 2 options are possible to select, either automatic or this one. I will use this one here. And so that's the spot color definition. In the proofing tab, we have 2 media wedges that we could enable. By default, we want one media wedge that simulates how our 7-color or CMYK or whatever we put into that queue is converted. So that's the most important one. There is as well a possibility to use a different media wedge for the proofer color space. This is useful if you want to check how consistent your proofer is. Let's assume I have created my Epson P5000 printer profile at a certain time. After that, I have changed my inks because I had to, because the inks are empty. Now the question is my profile still valid? And with this little additional media wedge, which would not be color converted, I can simply measure and compare it to the same media wedge that I had before that ink change, and see how strong the deviations are. If they are low, I can still use my printer profile, no problem without that. If the delta E's are high, then I better create a new printer profile for my proofer, because otherwise my proof quality would not be that high. And therefore, we have a second media wedge. I just used this one here. And obviously, I need some proofing information, which we will add on the proofing page. And we would add it at a certain position, and that position can either be automatic or one of those margin options. We add the media wedge and information to the external part of the media box. So that can be defined where that is. And there's just one thing here that we need to define. That would be under options. And here, the important thing is where our second spot color library would be selected. To exclude colors from the dynamic media wedge, we want to use a dynamic media wedge. And if you remember, we had those 3 spot colors, and one was a die cut, and the die cut is definitely not a spot color we want to have in our media wedge. And therefore, we select our non-printing color library here. Oh, I should look for N, right? So where's that? Here we go. So I select this one. And here would be my selection here. I can as well say how many tints I need in my media wedge. I could have the solid tones only for the spot colors, or even none if I don't want them, or 5 patches. I will add 5 here. Can be fine if I want to have gap size or not. The patch size can be defined, and the ruler definition would make for the default chart width. That's a typical dimension here that we would use for the I1 ruler, for example. The font size can be defined, and so on. So that's all done here and fine. So I'm now done with it. And now let's see what's happening if we are converting our files. So here again, I can simply right-click on a queue, open folder, and with that, I have the input folder. And from there, I want to put in my 3 files. And they are now going to be processed. There is as well one thing that we are setting up during the processing here. We can look into that in the edit queues. We see here that there is a folder for report and other data. So this report folder will be added from the auto setup wizard automatically. And that's an important folder here, because in that folder, we will position the reference data for our media wedge, because our media wedge is a dynamic one that we are creating here. And for each of the jobs, it will be a different media wedge. And for each of them, we need the device color data, and best would be as well the LIB data, so that we can compare our result at the end. And so that's what we are seeing now, what's going to happen here. So all the files are converted. They are now in the output folder. And here under reports, we have the text file from our media wedges. And let's have a look. Perhaps we start with our docs image here, which has been converted to RGB, our proofers in RGB color space. And what we are seeing here is that we have added a CMYK media wedge. We probably, if we zoom in, we probably even see a little bit of paper simulation here. So here is a white, and here is some paper simulation that you can see in the RGB values here. This is the media wedge. This is the information part, the job information for the media wedge with all the information that are necessary to make it a real proofing thing. This is our media wedge. And we would add that media wedge below in this example from that image. So that's a CMYK media wedge. From the cat food, let's have a look here. How would that look like? Again, everything is RGB, obviously. Here we have our CMYK media wedge. We have our information placed here beside, and we have 5 tints for our spot colors red and blue. Obviously not the die cut, because we have excluded that. So we have this information here. And the last one was this image here. If I open that in Photoshop, we'll see it is converted to my Epson. The profile is shown here. We see it is RGB. And here we have a larger media wedge because, well, our source color space was 7 color. And therefore, it is a bigger media wedge with more information that is needed to be placed in here. And here again, it has a paper simulation added to the media wedge, the same as it would be applied here to that image. And as we can see, that was the original viewing, the way how Photoshop views this multicolor, but it's not in true color, but that's rather how it would look like in reality. So vibrant colors, of course, but more true to reality, and that's what we can see here. So that's very nice. And if I'm going to look into those media wedge information here, we can simply load this in ColorEnt. ColorEnt is as well a tool from us that deals with measurement data. And we can simply load the 3 data here. And we will see exactly the same thing, starting with this fine print Jodrell poster, which was the CMYK part. We would see it has CMYK information. That's basically the layout as well from our media wedge. We could measure this as well here with our own tools and compare it with the comparing feature to see how good we are in proofing. Obviously, I don't have something to compare here, but this gives us already the information, all the information we need to measure it and to compare it to the LRB values, and we will fill this information automatically. So that's really a very nice functionality here. Our cat food has the CMYK plus the additional 2 spot colors here. Here again, we have the LRB information that we want to target, and we can check with our proofer how good we are in representing these colors. And the last one, obviously, was a 7-color media wedge, and here we have all this information as well. So the bigger information here with the media wedge for 7-color. And all this is automatically created from Zebra with all the information available so that you can work with that either directly in ColorEnt for measuring or use it in whatever kind of evaluation software you're using. Simply load the data because it's CGATS data, just some normal CGATS data that everybody should be able to read. And with that, you can import that in any kind of tool measure, and you get your evaluation with that. So that's how this works in Zebra. I just want to show you one little thing here. If I'm changing the patch information here, that only the solid tone for the spot colors should be added. I just want to do that to give you an indication what's happening then. I just want to convert this file, the cat food file with the spot colors. Simply in the process jobs area, you could right-click repeat job, and then the file can be processed again in that folder so that you don't have to search for that. Open folder here. So what's happening now is that we will override the existing cat food text file here with the new information, so that now we will have a different reference file with just the spot color from the full tone and not with the tints anymore. This way we make sure that the last kind of conversion that you want to do really is reflected as well in your reference file here. And after the processing here, I would just load that so that we can see what's happening. So this one, the cat food, has now only the full tones for red and blue here, whereas before it has the 5 steps of our spot colors. So this way we have the right media wedge for the right purpose, let's say.